Let us get started. Thank you very much for joining this webinar on C&I Solutions with GoodWe and GoodWe Solar. The whole purpose being, it's on how to ensure the perfect design for your C&I solution. Just for some housekeeping rules, we have a Q&A section on the Zoom platform, which can be used to ask any questions. We will address as many as possible on the back end with a message response, but any other ones we do not reach, or whatever's left at the end, we'll address in the Q&A section. In terms of our presenters today, we've got myself. My name is Andrew Tyler. I'm Sales and Business Development Manager for GoodWe for Sub-Saharan Africa. You'll be hearing from my colleague David Havenga, who is our Technical Manager for the same region. And then we have Daniel Pasca from GoodWe Solar, who's the Sales Manager for Southern Africa. Thank you very much for joining. We look forward to helping you guys look at the C&I solutions we offer, as well as GoodWe, and seeing how they combine to offer a perfect design for your solution. From my end, I'm just doing a quick introduction. Going into who GoodWe is on one or two slides, and then going into the C&I solar market for Africa or Sub-Saharan Africa as a whole. Our GoodWe family is quite large. There's around 3,000, in excess rather of 3,000 employees globally, as well as around 600 or more R&D staff. You can see the R&D makes up a big portion of our GoodWe family, as we call it. And the main reason being that, in order to stay ahead of times and ensure we offer very competitive and technologically advanced products, it's important that we have a team constantly developing and improving our products. On overseas employees, we have about 100 or more, of which myself and David are part of that team. And you can see we've got exponential growth in global sales revenue, which is always good, moving upwards in that respect. In terms of production capacity, so we have a production capacity of around 25 gigawatts for solar inverters and around 400 megawatt hour of battery capacity. To give you an idea, we have around 35 gigawatts of installations globally, which is quite a significant number, but that is growing rapidly each and every year that passes by. All right, then looking at the overview of the C&I market per region. So this graph is quite nice to look at as it splits the different parts of Africa. So you've got Northwest, East, Central African islands, and Southern Africa. You can see that Southern Africa still makes up a massive portion of the market. And then, of course, you've got some exciting things happening in North Africa, as well as Central, being, West and East Africa as well. What I've put a note there is we normally estimate, of course, this being the total market size, we estimate C&I to be around 25% of that market. So when you're looking at, this, graph specifically goes up to 2019, but you can see an installed capacity of roughly 6,000 to 7,000 megawatts. That would be, looking at the total market, including utility-scale plants, which make up a much bigger portion of around, as I said, 70-75%. Then in terms of, this is another perspective, which we source from IRENA, or India Infrastructure Research. Again, this is the total market, so just keep in mind that we're referring to C&I today, so you're looking at about 25% of that. But they say that, the cumulative capacity up until the end of 2020 was around 10.5 gigawatts, or 10,581 megawatts. You can see they estimate around 1.2 gigawatts, or 1,200 megawatts being added between 2019 and 2020. Look, it's, these type of things are very difficult to come across in South Africa or Africa. We don't have very good numbers to share, but this is what we can see. Ultimately, there is constant and significant growth every single year that passes by, and I think that we're seeing massive numbers going into 2021 and 2022. In fact, we see sometimes upward of 800 megawatts in South Africa alone, and there's some exciting developments happening in other countries outside of South Africa, which is really great to see. In terms of installed capacity, this is quite a nice look at the entire African continent, and we've highlighted a few countries that have seen significant growth in installed capacity. South Africa, being one of them. We have had a sort of bit of a head start, I guess, in terms of developing projects. And sometimes our policies allow for installations a bit quicker than maybe some other smaller markets. Then we've seen some exciting things coming out of Egypt. Egypt has some of the largest solar projects in Africa. And then they've also highlighted Algeria and Morocco. But we're also seeing, a lot of other key markets coming up, as we go along. I mean, in East Africa, you've got Kenya, you've got Tanzania. In West Africa, you've got the likes of, Ghana and Togo. And then, of course, in Southern Africa, we're seeing some exciting developments in Mauritius, and Zambia, Zimbabwe, Namibia, etc. I think we're seeing good growth, which I think is ultimately what we want to see, whether we're based in South Africa or somewhere else. We like to see the market grow, and there's some exciting things coming up. Just a quick challenges and drivers for growth. So firstly, we're going to cover the challenges. This is from my opinion, so I mean, you're welcome to disagree or agree. Firstly is, I think, knowledge and understanding. The biggest thing with C&I plants is that there's this misconception as to how they will work, how much money they will save when they function, what their costs are, what financing options available, etc. There's really a move to education, which I think is important. We like to educate customers. More often than not, myself and our team have meetings with property developers, end users, EPCs, finance houses, etc., to try and better understand what the challenges are and to try and move forward with these developments of projects. Then regulatory challenges. So I think it's a big thing in Africa, lack of rules and frameworks. So often there's not really net metering. There's no real benefit in exporting power into the national grid. You've got some issues with wheeling, for example, whereby some areas like in South Africa, the Northern Cape is kind of reached its capacity in terms of transmission lines, which means no more projects can really get built. So just, a lot of really regulatory things to overcome before we see the exponential growth we should be seeing already. There's also a massive impact on national utilities. I mean, in South Africa, Eskom, every time a commercial plant puts in a solar system, suddenly there's a customer that was maybe, paying for 6,000 kilowatts or 6 megawatts a day that's now no longer paying that to them. So, they have to in turn increase their electricity tariffs, which only but makes, solar plants such as C&I grid-side plants even more attractive. And then lastly, financial challenges. As I said, in Africa, there's been this really poor uptake of funding being offered. And I guess it's because of the shortage of track record in our markets, and also in certain markets there's currency challenges. Zimbabwe is one of those where there's kind of a dual currency being offered. Legally they've got their local bond, but there's still US dollar on that market, but it's difficult to gauge what price to charge the customer on a financed offer. So yeah, that's one of the biggest challenges. In historic terms, the size of projects in sub-Saharan Africa or Africa have been smaller, which makes them less attractive for funders. But I'm seeing a massive increase in funds and PPA providers coming into South Africa and Africa. And then subsidized electricity. We've seen in a country like Zambia, the government subsidizes electricity massively. I mean, they've got some of the cheapest electricity out there, and it's really a political thing from what we understand. But that makes the offer for PPA agreements, etc., not as attractive in other markets like ours or South Africa, where power is getting more and more expensive as each day goes by. And then lastly, the drivers for growth. One is, again, on the other side of things, understanding the benefits of solar. I think that's critical. And when your customer sees that they can pay off their system in a matter of 2 to 3 years, or even not pay for a system at all through a PPA provider, I think that makes it quite attractive. Finance options, we did mention that now, it's not just about having cash, available to spend. There are providers out there that will put a system on your roof and charge you a significant amount cheaper than what Eskom or your utility does. That is a no-brainer for a lot of these larger commercial customers. Simplicity and execution time of projects. I think, C&I projects are a B2B or business-to-business transaction. So it's a lot faster closure than utility, projects and government tenders. Electricity costs going up, a big one. It is nice for a manufacturing plant to be able to put in a system and know that during, the peak hours of sun or the sun hours in a day, they can save almost all of the electricity and move that load to during that period. The other side of electricity costs is also demand charges. Some plants pay an excess amount if they peak over a certain amount of power in a day. And that's one way of reducing that cost. The obvious one, electricity stability. I mean, we constantly go through load shedding in South Africa, and it's nice to sort of have the option of putting a grid-side system in with a diesel fuel saver or diesel power plant controller, so that when there is load shedding, you're not constantly running your full power on a diesel generator. You do have the option of reducing that by having some type of facilitation from the grid side system. And then often, not necessarily for us, all the time, but there are some, pushes to make buildings green and achieve green energy targets, reducing pollution, reducing your reliance on fossil fuels and things like that. So yeah, that's it from my side. I'd like to hand over to Daniel. Is it Daniel or David? David, apologies. Handing over to David now to continue with our webinar. Thank you. David, are you there?
Hi, yes, sorry, I'm just having a bit of a glitch. Let me just share the whole screen there. There we go. Zoom is not playing along with me at the moment.
Yeah, it says you started screen sharing, but it doesn't seem to be showing anything. Sorry about that.
I'm very sorry. No. Zoom has just decided to freeze my whole laptop.
Should we maybe move over to Daniel, just for the sake of time? Daniel, will you be able to present now?
Yes, 100%.
Okay, awesome. Thanks very much. And then we can move on to David afterwards.
Sure. Is my screen visible?
Not at the moment. Let's see. Let me just try and stop that. Okay, I'm just trying to share. All right, try again, Daniel.
Is it visible now?
There we go. Yes,
Perfect.
It is. Cool.
Fantastic. Yes, Andrew and David, thank you very much for having me today. And thank you for your presentation to start. It was very insightful. So my name is Daniel Pasca. I'm the sales manager for Southern Africa at JA Solar. just some brief information on JA Solar. We're a tier 1 leading PV module manufacturer. We were founded in 2005 with about 25,000 employees worldwide, with over about 1.5 gigs installed capacity in Africa at the moment. So today I'm just going to be discussing our DeepBlue 3 module line with regards to the C&I space, just to give an overview of, you know, the best levelized cost of electricity in terms of the 182 millimeter wafer. So, you know, over the years, you know, as PV module power has increased, we've sort of seen a link to the larger module cells being implemented with mainstream C&I. You know, as you look in 2009, the largest sort of cell module capacity was 290 watts, which has drastically increased to, you know, over the 500 watt threshold now as of 2020, and even further into 2022, which I'll go into more detail shortly. You know, upgrades of module power cell capacity has been done through PERC technology, through, you know, increased efficiency, and then of course through enlarging the cell size itself. So as I said, you know, cell efficiency has really increased from about a 17% range in 2009 to about 23% now in 2020. And, you know, further increases are bound to happen as technology increases in the future. As I was saying, the cell capacity, or sorry, the cell size was about 125 millimeters, which is now, you know, increased drastically over the years to mainstream at the moment, which is 166 millimeters, 182 millimeters, and then for the larger power classes, say 550 watts upwards, 210 millimeters. If you're considering, you know, larger module capacity for C&I space, it really does start make sense, you know, implementing the 182 cell, the 210 millimeter cells. As the power class increases, the balance of system starts to reduce drastically. So I mean, from the table you can see the 415 watt module has a variable balance of system cost for about 0.64 US cents a watt. Now, if you take that into consideration for the 590, 182 millimeter 78 cell, it drops to about 0.046 US cents per watt. Now, in reality, you know, if you're considering a 10 meg plant or a 5 meg plant, it adds up very quickly on balance of system, you know, in terms of cost reduction. Obviously, here's just some more information on balance of system costs. You can see as the efficiency of the module power increases, the balance of system does take a reduction. Now, there is a lot of, you know, sort of discussions in the market. Is it better to use higher power class modules? We found specifically that the sweet spot is typically in the 450 to 540 to 550 range for the C&I space. As you start, you know, going to power classes larger than that for C&I, it does become a little bit tricky. For example, the 590 or 600 watt, there is less kilowatt capacity able to ship per container versus the 540 watt. So, I mean, really the sweet spot in South Africa is the 166 and the 182 millimeter cell power classes. Oh, sorry, not just South Africa, for Africa, you know, as a whole. So considering some voltage and current information for the modules, as you can see, higher voltage for lesser current for the 182 millimeter cells and for the 210 millimeter cells. This is obviously due to half-cut technology. And then considering the larger, you know, 210 millimeter cells can get a low voltage output with a higher current output. So here's some more voltage and current information, just some key parameters on our larger modules, say the 590 watt, open circuit voltage at 53.3 volts, and then for the 210 cells, 41.16. Now, considering the voltage and current, if you have a look at some of the charts, you can see if you take the daily radiance, it matches perfectly to daily module current and daily resistive losses on our larger cells. Now, we've seen significant advances, with the inverter manufacturers over the years. I mean, with the implementation of larger, modules, it has taken some time for certain inverter manufacturers to essentially catch up to be able to cater for the larger strings inputs for the modules. So as I was saying, the 182 millimeter cell is typically more preferred in the African market at this stage. If you're considering it from an installation point of view, higher kilowatt peak rating can fit in a container, so it accounts for lesser cost shipping. Installation is essentially quicker, there's less cabling needed. The modules themselves are relatively large, so they do require 2 people to carry one, for example. But if you're taking the overall cost of the balance of system, it does work out cheaper in the long run to look at a higher power class module. Here's just some survey data that we've conducted with the TV authorization. So as you can see, the site data was taken over various batches of modules installed in relation to operation temperature of the modules themselves. This further continued. Okay, so to jump into the module configuration itself, we'll be specifically looking at the 182 millimeter half cut cell. Now, some of the advantages of the cell is we have PerChem cell technology, which is a more high efficiency technology for our modules itself. There's 11 bus bars on the modules itself. Half cut technology. So essentially, each cell is split in order to limit factors like shading, for example, and to have better power output. Obviously, the big one is the cell sizing upgrade. So as I was saying, as technology has increased and as the larger power classes have become more popular, cell sizes have increased all the way up to 182, and 210 is sort of the new hot topic at the moment. Here's just some information on regards to PerChem technology. So I mean, that has also been one of the factors that we've worked quite hard on over the years to increase the efficiency of the cells, with the newer PERC technology being implemented, such as a better long wavelength structural response on the modules with lower irradiation properties, meaning that modules can produce at a higher efficiency even at lower solar irradiations, and as well as high efficiency at lower temperatures. Now, one of the other patented technologies that we have implemented is gallium doping wafers. Now, this is one of the main benefits of the weighing facilities of increasing modular efficiency. So as you can see, by implementing an M10 a gallium doped wafer, we can lower degradation of the module. So setting it at 2% over the first year, and then 0.55% per year thereafter. And that's on single glass, and double glass it's the same, except for 0.45% thereafter for 25 to 30 year period. Here's some information about the busbar technology. Typically the 182 millimeter cells has 11 busbars per module. There's a reduced risk of cell cracks with this sort of implementation. Now, considering half cell technology,
Daniel, we've lost you there. We can't hear you.
Sorry, can you hear me now?
Yep, we can. Thank you.
Okay, 100%. Sorry about that. Yeah, so as I was saying, half cell cut technology. Considering the modules itself, it really allows for a lower temperature coefficiency for the modules. So as I was saying, allows modules to produce at a high yield with lower temperatures, as historically it wasn't really the case. you needed essentially higher temperature in order to get the best out of the module performance. So here's some of our technical parameters around the DeepBlue 3 series modules, the 72 cell and the 78 cell. A 0.35% degrees Celsius temperature coefficient per module, 98.5% low light performance, and a module size of about 2.2 or 2.3 square meters across the 590 and the 540. As discussed earlier, it was a 2%, degradation over the first year for both modules, with a 0.55 and 0.45 thereafter over the lifespan of the module. And as you can see, single glass is significantly less, weight capacity for the double glass. Now, going into a bit more information on the DeepBlue series itself, with regards to the upgrades that we've managed to implement over the years. As you can see, what has been discussed is the 11 buzz bars, the half cell cut technology, and then the gapless flexible interconnections. So that's something that's relatively new for JA Solar itself, to eliminate spacing on the module to fit more cells per power class capacity. Now, considering cost analysis on using the larger 182 or 210 millimeter cells, if you have a look at, for example, package substations, inverter installations, inverters, communication, cabling, that sort of thing, you can definitely see that cabling, cable wiring, support, and pile foundations really make up the bulk of the balance of system when looking at larger power class implementation. Installation point of views, it is a lot faster to install the larger power cells, with less cabling. There's less maintenance and operations required. So it does definitely make sense with installing the larger power classes. We've definitely seen an uptake in the C&I space for the 182 millimeter cells over the last year. I think specifically with the 100 megawatt threshold being reduced, it has been a pivotal, point for the increase of C&I installations over the South African and African market. Here's just a bit more information going into detail on levelized cost of electricity benefits of implementing the larger modules. So here you can see a specific project in Dubai for 100 megawatts with the relative cost definitions per module capacity. So, levelized cost of electricity overall reduction from the 158 cell to the 210 is the bottom line, which you can see the 182 millimeter cells are essentially the sweet spot for a project of 100 megawatts, for example. Here's just some more information based on the previous slide. Yeah, and that's it from my side.
Awesome. Thanks very much, Daniel. I thought maybe we can quickly just answer those two questions since it's relevant to your presentation. The first one, well, it's actually the same person twice. The first question is, what is the best module power range from JA Solar for C&I rooftop, 450 watt, 500 watt, or 550 watt?
Sure. It really depends on various factors, but I mean, the sweet spot in Southern Africa specifically is the 460 watt to 545 watt at the moment. We are seeing an uptake for larger power classes, for example, the 590 or the 600 watt. But with the larger power classes in the 590 to 650 range being a relatively new commercial product offering for C&I space from JA Solar, we're still pushing the 166 and the 182 millimeter cells at this stage.
Sure. Yeah, look, I think from an inverter perspective, it's the same. I mean, it's funny how the market is, whatever's available is what they use. So we've seen, a 5 kilowatt inverter for a home having 550 watt modules used on it. I think It's just one of those things, so and then the second question was, what do you expect as a timeline for the shift to N-type technology in C&I?
We're looking at, having N-type commercially available within the next year and a half. It's difficult to put an exact timeline on it at the moment. And then the next factor would be how fast can the market adopt to the new technologies. But I think the main challenge will be, moving away from our current, product offering to N-type will be the sort of longest time frame. So I'm expecting, let's say, 1.5 to 2 years.
All right, awesome. Thanks very much for that. David, please go ahead.
Perfect, thank you. Hopefully you can hear me properly.
Yeah, all good.
Sorry about the language. Technology doesn't always work with us. Sometimes it works against us. So I'm just going to be going through mainly focusing on our HD products. We also do have the MT, which is very often used in the C&I range as well for your smaller projects, the 50s, 60s, and 80 kilowatt inverters. But we'd like to showcase the HD in this sense. So these are more commonly used now. So any 100 kilowatts, 200, 300, 400, up to a megawatt, even larger, will all be using our new HD inverters. So you'll see we have multiple different modules, 100, 110, 120, or 1100 volt DC at normal 400 volt AC. So these are all your normal rooftop inverters, but can also be used for ground mounting. The 100 kilowatt has 10 MPPTs, the 110 and 120, and all the rest all have 12 MPPTs. We have a 136, you'll see that's 500 volt AC, that's going to be mining applications and things like that. And then the 250, which is more utility scale for big utility plants. These devices give us high energy yields, lower investment costs, simple O&M, and reliable quality. So let's look a bit at the higher energy yields. With 12 MPPTs, you have a lot less array losses or chance for array losses. Normally when you're combining a lot more strings, especially on central inverters and such, we know a small defect on modules or fault floor, things breaking on site, typically can have a large impact on production. But by splitting the arrays more, having more split arrays, when you have faults on site or module damage or theft, your plant can normally still run perfectly fine, even if you lose a few modules here and there. Our devices also allow that 50% DC oversizing, so essentially you can have less inverters with more capacity for increased yields. With that as well, our inverters also give a 10% AC boost, so they can produce 10% over their rated power. So the 120 can give you that extra 10%. So if you worked on the hundreds, the 100 will give you 110. As you'll see here, so 1 megawatt out of 100 kilowatt HDs will give you a 1.1 megawatt AC output, as long as it's within temperature range. So especially if you are DC oversizing for winter months or different months where you might have lower irradiation or higher temperatures, which will reduce the maximum irradiation you can get out of your modules, that DC oversizing does give you that benefit. And when your production is good, your inverters can give you that extra 10% output. As you'll see, our HDs give that 110% output to 45 degrees Celsius ambient. Only at around about 50 degrees Celsius is it at 100%, so we only derate after that. All our devices are fan cooled, so they do have IP68 rated fans, which does help with this derating and gives them a lot longer production at higher temperatures. That's just a reference of curve. So we also have lower startup voltages, especially for such big inverters to only start up at 200 volts, the production. So that will give us a longer production window. And especially using more MPPTs, you might have some of your strings already early morning, having availability in sunlight, and those can start producing until the rest of the strings are become lighted up. Our device is also compatible with all newer modules, as JA's modules have displayed. So they go up to 14 amp short circuit current on some of the modules. So we can only see current will most likely be increasing, as the modules get larger in wattage, they have to increase the current. So our inverters already can do 15 amps per input, where we have 30 amp MPPTs. So that 30 amps gives you a lot more leeway. You can essentially only put one string if it's a much higher current, 18, 19, 20 amps with some of the other half-cut cells, and that works perfectly fine. This is just a brief overview of what we saw. So the multiple MPPTs, so 10 on the 100 and 12 on the rest. Startup voltage is quite low at 15 amp DC current input. So we are compatible with some of the tracking systems, with third-party solutions, high temperature adaptability, 45 degrees Celsius, and AC overloading to maximize the output, and our 50% DC oversizing. Now let's look at some string designs. So these are just some designs that I put together just to showcase how we could use these inverters along with some of the JA modules, the new modules. So yeah, I've got the 545 module connected to the inverters. As you'll see, we're utilizing all the MPPTs here, so 18 panels per MPPT, just one single string. That gives us a total of a 98.1% DC coverage. So that's about 111,700 kilowatts on the inverter itself. So not a full 120. So obviously we won't get that 10% extra. But sometimes the site only requires so much. So this is also just. For this one, we could have used the 110 or even a 100 kilowatt inverter, which would have been sufficient. Next, we're looking at utilizing more, almost up to that 150% DC oversizing. As you'll see here, I did 2 strings of 13 modules each. That's a 141% DC to AC ratio. So it gives us a 41% DC oversized over and above the inverter maximum. So you see this can help to improve those yields. So all year round, we can look at the comparison. So all year round, we can get a lot more production. And then we have another example. So because we can, this is a 120 kilowatt inverter. We've oversized it by 14%, so that's 114% on the DC. We're only using 7 of the MPPTs, so that's 2 strings of 18 modules connected to each MPPT. The only thing we have to be careful with this, because each of our MPPTs is going to have a set power limit. So when we connect all of these up, we might see some clipping happening, but this should just be in range of what the inverter can physically deliver per MPPT, and then a configuration like this will give us quite a good output and have less strings. But in a case like this, we will be losing a little bit of that efficiency compared to something like this where we're utilizing all those MPPTs. For a case like this, you could use something like this. You just add 1 or 2 more strings here to increase your DC oversizing and split the rest of the strings across your MPPTs. So that's obviously going to give you your best overall yield in the long run. So when your modules are new, everything's clean, there's no damage, everything's working perfectly. We're not going to see a great benefit on splitting the strings like this. But over time, when they're swelling, all those different kind of situations that do happen on site, this is where we're going to see that extra production coming into play. But this is a possibility which some installers may use, but I always say try and split them up if you can to always give you best results. And then next, connecting the strings up to the inverter. As you'll see, this is a diagram out of the user manual. So this diagram shows us the internal wiring of the inverter. So I just like to highlight that to you a bit, just to show. So you'll see here's MPPT1, PV1. We've got our input 1 and 2. So input 1 and 2. As you can see here on this line diagram, input 1 has a CT. That CT is limited to 20 amps. So if you have a 18 amp module, you know, that isn't any problem whatsoever. Sometimes we might combine modules before we reach the inverter. If that is done, we can see this secondary CT, you know, after the combining and the filters, we have another CT. So that CT is the full MPPT range, so more than 30 amps. So if we are going to combine strings or have even higher modules in future, higher current modules in future, it's always best to use the second input. So always use the even number inputs, so 2, 4, 6, 8. That will give us the ability to use that combined string and not have any limitations of ACD current as yet. And just a nice view for you of the bottom of the inverter, just to show exactly what we meant. So yeah, you'll see input 1 and input 2. So input 1 has that 20 amp current limit, and input 2 does not have any current limit besides the MPPT current limit. So in this case, we can use 2, 4, 6, 8, 10, 12, and so forth. So that's if we are combining strings or using more than 20 amps strings. So luckily our module guys aren't there yet, but who knows, one day they might have modules that give us 30 amps, so then we'll have to use one input. Yes, and then just quickly a touch on our inverters and the reliability. So all our inverters do have redundant protection internally. We do use DSPs, which is digital signal processors. So we all have dual signal processors, DSP processors in there, and all of our relays. So especially for AC, we've got double isolation relays, you know, for isolation and protection. As is a regulation in many countries, we do have this in all of our devices. All our devices do go through rigorous testing before they leave our factory. So not one of our inverters come out of the factory without a bit of vigorous testing. So all go through the IP testing to make sure that no humidity can get inside there, high temperature testing, noise, vibration, stopping testing. So starting testing with cycles, and spray tests as well to make sure that our IP rating and everything is perfect on our devices. Obviously in our labs we do have, so when we do design and develop products, they do get age tests. So you'll see all of our devices when they're produced, for at least 8 hours they are tested in our site to make sure they are reliable and work well in high temperatures. So that tests all the thermal conductivity, make sure there's no loose connections, all those kind of things. So all our devices are well tested in the laboratory before they leave our factories. Our production lines are ISO 9001 certified. So there's an internal structure throughout all of our production lines, and we do have an anti-static plant. So everyone, before they work on everything, have anti-static wrist braces and all those things to make sure that no components can be damaged by static electricity. And yes, that's all I have from my side. Do we have any questions?
Thanks very much, David. Appreciate it. Yeah, for the questions, guys, again, there is a Q&A section. So please do ask anything. Otherwise, we can also provide our email addresses in the chat box in case you'd like to reach out for some questions. But I will give you guys another minute to ask any questions, and then we'll close off.